We're working here in class these problems that came from the end of that worksheet that we were talking about last time on inverse trig functions. So you have to remember the ranges of inverse sine and inverse cosine. So the answer to an inverse sine, the range of an inverse sine, has to be an angle between negative pi over 2 and positive pi over 2, and the range of an inverse cosine has to be between 0 and pi. And we're going to take the tangent of both sides here. That will just give us x is 2. Now on the 5 and 6, you're going to have to draw a triangle.
So pi over 4, so that's at 3 degrees. So for sine over cosine, well, let's just do it this way. Sine over cosine.
So we are saying that the cosine of an inverse sine, this is an angle whose sine is x. So if we draw a triangle and we say that sine is going to be x, that means the opposite over the hypotenuse is going to be x over 1. We can do some Pythagorean theorem and get that this side is going to have to be the square root of 1 minus x squared. Now we can take the cosine of this angle, that's going to be adjacent over hypotenuse. And so that is going to be the square root of 1 minus x squared. In a similar fashion, if we want the angle whose secant is square root of 5 over 2, since cosine is adjacent over hypotenuse, secant will be hypotenuse over adjacent. So we'll label our triangle where the hypotenuse is square root of 5 and the adjacent is 2. From Pythagorean theorem, we can get that opposite side is 1. So the tangent of this same angle is going to be opposite over adjacent. We'll get to there. Okay, so we're just reviewing what we got from yesterday. So the derivative of an inverse sine, does anybody know that?
1 over square root of 1 minus x squared.
Nice. So if we know that the derivative of the inverse sine is 1 over the square root of 1 minus x squared, then we automatically know the derivative of the inverse cosine is negative 1 over the square root of 1 minus x squared. So it's a 2-for-1 deal. You just got to remember one of them. The derivative of an arctangent is
1 over 1 plus x squared.
good. So if we know the derivative of an arctangent is 1 over 1 plus x squared, you automatically know the derivative of an inverse cotangent is negative 1 over the square root, 1 plus x squared. So again, a 2-for-1 deal. A derivative of an inverse secant is the most complicated one. That is going to be
1 over absolute value of x square root x squared minus 1.
and notice you got to have the absolute value or it's not correct. It's the reverse order of what you see with an inverse sine. So they both have a square root, but the inverse sine leads off with the 1 and the inverse secant leads off with the x squared. That matters. So then we know the derivative of arc cosecant, arc cosecant is 1 over, gotta have the absolute value still, square root of x squared minus 1. Okay. Jot those down in your notes so that you know them. So I'm going to erase them and we're going to do some chain rule with these things. These must be known from memory. I see in the very near future quizzes involving these and product rule and chain rule and on and on. Okay. Did you get that? Okay. So let's do, we'll say f of x is equal to the inverse sine of x squared. So this is going to be a chain rule derivative. We want to do f prime of x. Should we do it together?
No.
No?
No.
Should we do it at the board, Miranda? What do you think?
Well, they can.
They should do it at the board, you think? I think that's a reasonable expectation. So it's going to be du over the square root of 1 minus u squared. So let's try another one. Let's do the derivative of inverse tangent of e to the x. So remember, the derivative of an inverse tangent is our structure, our formula, the thing we have to have memorized with a chain rule is going to be du over 1 plus u squared. So we have du is just e to the x, and e to the x squared, remember, is you're just going to multiply the exponents. So it's e to the 2x. Let's do if y is equal to the arc, let's do arc cosine, two c's in there, of 5x. And let's find dy dx, its derivative. So we are getting the du, which a negative du, which is going to be negative 5, and it's a square root of 1 minus u squared. So when we square the quantity 5x, we're going to end up with 25x squared. So let's say g of x is going to be the arc, let's say secant of, and let's say e to the 3x. Has a little tricky simplification. So we're getting du over, we want du over the absolute value of u times the square root of u squared minus 1. So the du is the derivative of e to the 3x. Well, that is a chain rule derivative. That's going to be e to the u du. We started with the absolute value of u as being the absolute value of e to the 3x. We have the square root of u squared, but e to the 3x squared, we multiply the exponents. That's going to be e to the 6x. Now, before we pat ourselves on the back, we think this exponential can never be negative. Right? An exponential lies completely above the x-axis. It's always positive. So it doesn't need an absolute value to make it always be positive. So once we realize we can drop the absolute value, now we can cancel those e to the 3x's. So our final simplified derivative is going to be 3 over the square root of e to the 6x minus 1. So f of x is going to be the arc cosine of x over 5. And we want to find f prime of x. And remember, our chain rule derivative of arc cosine of u is going to be a negative du over the square root of 1 minus u squared. So let's see where we are just with the calculus part. So the negative du, the derivative of 1/5 x is 1/5, and the negative is going to make it a negative. In the denominator, we have the square root of 1 minus u squared, which is going to be x squared over 25, or 1/25 x squared, either way. Now, we can't leave fractions in fractions, so we're going to, inside this radical, so inside the radical, if we just focus on that, we're going to factor out a 1/25, that common denominator, the least common denominator. Now, when you factor out a 1/25, you are dividing by that 1/25, so this 1 is going to become 25, because 1/25 times 25 will take us back to that 1. So that's going to make that 1 into a 25. When we factor out the 1/25 here, what's left is just the x squared, which is what we're trying to do. That's so far okay? So we still have the negative 1/5 on top. Now, inside that radical, when you have two things that are being multiplied, the 1/25 times this 25 minus x squared, we can take the square root of this times the square root of that. The square root of 1/25 is 1/5. That's what comes outside of our radical, is that 1/5. And the 25 minus x squared is staying inside. With me? Now, we can cancel those. And so at the end of the day, what we're trying to get to is -1 over the square root of 25 minus x squared. Okay, let's take your seats, and I want to talk about how to find the derivative of natural log x here. So quizzes involving inverse trig derivatives are going to be in our future. Okay, so we know the derivative of e to the x is just e to the x. We also know the derivative of e to the u, where u is maybe something more complicated than x. Our chain rule, as applied to the exponential base e, is the same exponential times the derivative of the exponent. Okay, so we're going to use that fact here in kind of a weird way to figure out what the derivative of natural log x is. So we know that an exponential base e and a logarithm base e are inverses of each other. So that means e to the natural log of x is actually equal to x, right? Okay. We're going to start with this, and we're going to take its derivative using the chain rule here and this idea that we're going to get e to the u times the derivative of the exponent, which we don't know, but we're going to solve for. So I'm going to take the derivative of both sides here. So on the left side, we said we're going to get e to the u, that same exponential back, times the derivative of the exponent, but I don't know that. So I'm just going to call it for now the derivative of natural log of x. So that's my e to the u du. That's equal to, on the other side, I'll get this one. The derivative of x is 1. You with me? Now we're going to solve for this thing we don't know, the derivative of natural log x. So I'm going to divide that to the other side. And so we're going to get that the derivative of natural log of x is 1 over e to the natural log of x. But we said e to the natural log of x is what? X. How about that? The derivative of the natural log of x is 1 over x. So the chain rule, as applied to a logarithm, if that u is something more than x, is going to be, and you can think of this one of two ways. You can either call it 1 over u times du, or some people will just shorten that up and say it's du over u. Whatever works for you. 1 over u du, or du over u. So let's see what that looks like. And we'll review some property of logarithms here and see how that's consistent. So if we say f of x is equal to the natural log of x squared plus 1, then f prime of x is going to be what?
2x over the natural log of x.
No, not natural log. There's no more natural log, right?
2x over x squared.
So here's the du, the derivative of x squared plus 1, over the u is the x squared plus 1. Kind of cool? How about, here's one that we'll get a chance to use, maybe review our property of logarithms. First, we'll just do it straight up. So the derivative of natural log of 3x is going to be what? 3 over 3x, which is just 1 over x, right? Well, think about it for a minute. Go back to your properties of logarithms. The log of a product is equal to what? Natural log of 3 plus the natural log of x. Remember that? Log of a product is sum of the logs. Now take the derivative. This is just a constant. What's its derivative? 0. The derivative of natural log x is 1 over x. Kind of cool? Similarly, we take the natural log of x squared. Let's first do its derivative straight up, and then let's see how that's consistent with the properties of logarithms. So just treating that as 1 over u du, or du over u, we're going to get in the numerator 2x over x squared in the denominator. We okay? Simplify a little bit, we can cancel an x, and we're going to get 2 over x. Okay, remembering our property of logarithms, the natural log of x raised to a power, we can bring that exponent in front. Right? Now take this derivative. The derivative of a constant times a function is the constant times the derivative of the function. So its derivative is going to be 2 times the derivative of natural log x, which we know is 1 over x now. What's going to be there? 2 over x. If you get something that's big and ugly, use your properties of logarithms first. Y equals the natural log of x squared, square root of x plus 1 over, we'll say, the 4th root of 4x plus 3 quantity cubed. Oh, like them apples, huh? All right.
Please excuse the interruption.
Ah,
Life Touch is here at the west end of the commons. If at the beginning of
don't do the
6th
derivative
hour,
first.
we could have last name, if it starts with A through Q, A through K,
Log of a
K
quotient,
as in
difference in the
karate,
logs.
in the commons 6th hour. Once again, A through K in the commons. Please remember to social distance. Thank you.
With me? Log of a product, sum of the logs. And I'm going to write the square root as an exponent because that's where I'm headed next. With me? Minus natural log, I'm going to go 4x plus 3 to the, what would that be? 3/4 power. You with me? Bring the exponents in front. I haven't done any calculus yet. Okay, now we're ready to take a derivative. This is our y, now we'll take our derivative. So derivative of a constant times natural log x is going to be the constant times 1 over x. It's going to be 2 over x. With me? Derivative of a constant times natural log of u is going to be the constant times. What's the du going to be? Over the u. Minus the constant times du over u. 3 over 4x plus 3. Okay, so 2 over x plus 1 over 2 times x plus 1 minus 3 over 4x plus 3. So the derivative is way easier if you do the algebra first. Otherwise, that is going to be a miserable du. In 1 minute, can I do change of base? So y equals log of x. What if we want to find its derivative? Log of any base other than e. So I'll show you next time, but we can do a change of base by making it into the logarithm we want, divided by the natural log of the old base. So that's really just a constant, weird constant, times natural log x. So its derivative is going to be that weird constant times 1 over x. Okay, and so we'll do a derivative of a logarithm other than base Euler's number. All right. Very good.
Gross logs.